Welcome back, everybody. Our next set of notes is a review of domain and range, and then also a little something new of writing interval notation for that. These are a little bit long today, so just a forewarning. I think I forgot a thing. All right. So at the very top of your paper, we have domain. Domain is the set of independent values, which are x. So we're going horizontal from left to right. And then the range are the dependent values, thinking lowest to highest, going vertical. And that's the y. Y is dependent on x again because we are picking the x values and plugging them in. Y, the answer, depends on what we pick. So I'm going to go through all of these parent functions. These are called parent functions because they're just a base function where we haven't added, subtracted, multiplied, divide, or put any negatives with for any types of transformations. We start with the linear function. F of x is equal to x, which is the same as saying y is equal to x. To make a graph for this, I'm going to go ahead and make an XY table. You can pick any 5 values you want. I'm going to go ahead and pick -3, -1, 0, 1, and 3. So if I plug -3 in for x, then we get y is equal to -3. If I plug the -1 in for x, we get y is equal to -1. If I plug 0 in for x, we get y is 0, 1, and 3, because you can see the pattern from there. So if I draw this, plot and draw this, you have -3, -3, -1, -1, 0, 0, 1, 1, 3, 3. You can see that this is just a straight line. Probably grab a ruler if you can and make those. So domain. For domain and range, we're looking at the quote-unquote ends of the graph, or at least where we have our graph starting or stopping. On the left side of my graph, because remember domain is from left to right, we have an arrow. Arrow means infinity, and going to the left is -infinity. Then we have x because domain is our x values from left to right. And on the right side, we have an arrow as well. An arrow going to the right is positive infinity. So -infinity to positive infinity would be our domain. Our range, down at the bottom of our graph here, we have an infinity again. Going down is -infinity, is less than y, is less than, and then again at the end here, going up, we have an arrow going towards positive infinity. So those are our inequalities. Our values on this line are more than -infinity, but less than positive infinity for both domain and range. In interval notation, we go from -infinity on the left to positive infinity on the right. Infinities always get parentheses. Same thing with range. We have -infinity on the left and infinity on the right. They get parentheses as well. That will be our linear function. Absolute value. Remember that absolute value is always positive. F of x is equal to the absolute value of x is the same as y is equal to the absolute value of x. And so we can, again, pick any 4 values that you want. Maybe this time I'm going to pick -4, -2, 0, 2, and 4. Do they always have to be the same positives and negatives? No. I'm just trying to make it a little easier on myself. Plugging in -4, we have the absolute value of -4, which is 4. the absolute value of negative 2, which is 2. The absolute value of 0 is 0. The absolute value of 2 is 2. And the absolute value of 4 is 4. Plotting these on my graph. I have my points. Do my best job to draw a straight line for you because I can't get a ruler on here. And that's what our graph looks like. It's a V. Our domain. Again, our domain is from left to right. On the left side of our graph, we have an arrow. Arrow goes to negative infinity on the left. Domain is X, so we always have X there. And then on the right side of our graph, we also have an arrow. So that's going to be positive infinity. Interval notation, our left side is negative infinity. Our right side is positive infinity. Infinities always get parentheses. For the range, the lowest part of our graph is right here at this point. This point is filled in, and that y value is 0. Because it's filled in and it's the lowest point, we're going to have equal to and less than. And then at the top of our graph, we have arrows going up. Going up is positive infinity. For interval notation, we have 0 on the left, infinity on the right. The 0 is a closed circle and equal to, so that gets a bracket, and infinity always gets a parenthesis. Our quadratic, y equals x squared, or f of x is equal to x squared. Remember, you can pick any 5 x values that you want, but whatever you pick, you have to graph. When I have squares and cubes, I tend to try to keep them smaller numbers because they're easier to graph. So I'm going to do negative 2 to positive 2. And remember, you're plugging these in for x. Negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. If I plot this, we have here, 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 and here. And there's the gist of my graph. Domain, left side of my graph over here, we have an arrow. So even though it's pointing up, it is still going to the left. X values to the left over here are negative, so we still have negative infinity. On the right side, we also have an arrow. Yes, it's pointing up, but going to the right here on my x's is positive values, so that's positive infinity. For interval notation, we have negative infinity on the left, infinity on the right, and those get parentheses because they are infinities. For our range, our lowest value is this plotted point right down here at the bottom of our graph, which is at 0. That is a closed circle, so it's equal to. At the top of our graph, we have arrows going up to positive infinity. For interval notation, we have 0 on the left, infinity on the right. The 0 is a closed circle or an equal to, so that gets a bracket. And the infinity always gets a parenthesis. Cubes. X to the third. We have y is equal to x to the third power. Again, I like to keep my values smaller because we're taking something times itself 3 times. So I'm going to again go with the negative 2 to positive 2. Negative 2 to the third power is negative 8. Negative 1 to the third power is negative 1. 0 to the third power is 0. 1 to the third power is 1. And 2 to the third power is 8. So I'm plotting these. There we go. Kind of looks like that. And let's see, domain. The left side of my graph is over here. That's an arrow. Yes, it's pointing down, but remember, we're also talking about going to the left. Those are negative x values, so we have negative infinity. On the right side, we have an arrow going up, but it is also going to the right for these positive x values. Interval notation then, negative infinity on the left, infinity on the right, and infinities get parentheses. For the range, we have an arrow at the bottom going down. That's negative infinity. Range is y. Going up, the very top thing we have is an arrow. So that's going towards positive infinity. So they have the same for domain and range. On the back side, we have square root function, the square root family. Remember, this is the same as y is equal to the square root of x. Now, I encourage you to plop some numbers in your calculator, but you will find that you cannot take the square root of a negative number. If you remember, if you did like the square root of negative 4, it's going to give you an error. And we're going to talk more about that this year. But we have to keep, for our square root functions, our x values positive. So I'm going to go with 0, 1, and I want to pick numbers that I know have a square root to make it easier to graph. So the next one that would have a square root would be 4, and then 9. And I'm going to stop there and not have our typical 5. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So I'm going to go ahead and graph those. And we're going to go like that. Domain. Well, on our left side, we have this ordered pair. We can't go any further to the right because we're having errors with taking square roots of negative numbers. So the left side, we have a 0. That is a filled in circle, so that'll be equal to. And then on the right side, we have an arrow, so that's going to positive infinity. For our interval, we have 0 on the left, positive infinity on the right. The 0 is a filled in circle, so it gets a bracket, and infinities always get parentheses. For the range, our lowest value is also this very first point here, so my lowest y value is also 0. And it's filled in, so it gets an equal to. We have y. And then we have an arrow. Even though it's pointing to the right, it is still, these values are going up ever so slowly. And so we will call that positive infinity as well. We have 0 on the left, infinity on the right. The 0 being a closed circle makes that a bracket, and infinity always gets a parenthesis. Cube roots or third roots. Y is equal to the third root of x. We want to double check this again in the calculator, and we talked about how to get that third root in your math button. But you actually can take the third root of negative values. So I'm kind of actually going to go back to the front side of this page and use negative 8, negative 1, 0, 1, and 8 from our x to the third, the y values on that. And if I do the third root of -8, I get -2. If I do the third root of -1, I get -1. The third root of 0 is 0. So if you can see, it's actually the same as the table that you have for the cubic function, just flipped around. If I'm plotting this, kind of looks like a really weird long S there. But it takes the one that you had drawn and flips it around a little bit there. All right. So again, for a domain on the left side, I have an arrow to the left going -infinity. On the right side, we have an arrow going to the right, which is positive infinity. For the range, the lowest part is still this arrow on the left. Even though it's pointing left, those values are going down just ever so slightly. And so that's still -infinity. Range is y. On the right side here, the top part of the graph technically is another arrow. And these values are getting bigger, even though it's just by little bit. So getting bigger means it's going to positive infinity as well. So our interval notation is -infinity to infinity with our parentheses. New this year are going to be these two graphs. And so I'm just going to gently introduce this. This is the graph for it. This y equals 0, you see this kind of dots right here. This is called an asymptote. And our graphs never cross the asymptote. Never cross the asymptote. And so looking at the graph, we have an arrow over here on the left. That arrow pointing to the left means our domain is going to -infinity. On the right side of our graph, we also have an arrow, and so that is positive infinity. That interval notation is familiar at this point. For the range, the lowest part of our graph is this y equals 0 asymptote. So 0, but it's also never going to cross or touch the asymptote. So if it can't touch the asymptote, it can't be equal to that asymptote either. Up here at the top, we have an arrow for positive infinity. So the left side we have a 0, the right side we have an infinity, and because we can't touch that asymptote, that's going to be a parenthesis and a parenthesis for the infinity. We have the same case over here for the rational functions. The graph will never cross or touch asymptotes. There are two for rationals. We have one here at x equals 0 and one here at y is equal to 0. And I'm going to leave this one for right now. We won't worry about that. We're going to pause here for our notes and pick this back up in class tomorrow. Thanks so much for joining me. Have a great rest of your day.